Hello everyone, today we will design 2D truss frame span length 60 meter. Now we have to start from the new model and we call it 2D truss frame span 60 meter, and we click on the nationality of the United Kingdom and the language is English language. Click OK, and now I have to seal the model to prevent any error occur during design modeling. Now we have to change the view to exit direction, and we have to model as a line element. Then we have to assign to the texture element 15 meter length, and we have to move it. We have to move it. Click on move it. Click on the base point and minus 30 meter length. Okay, and we have to draw again. The length is 19 meter high, and we have to draw the top chord here, and we have to copy it to the bottom chord. Is 3 meter length. Okay, again 3 meter length. Okay, and we have to add the end node is 20. Okay, 20. Now I have to draw for diagonal, and this one we have to copy it to 18, and we have to copy the last one. Oh no, input 1. And now we have to create another column because one column is not stable for the long frame structure. We have to create another one by clicking copy again, and we have to add in the x direction 1.5 meter. Okay, now we got everything fine. We have to trim this segment by clicking on geometry, trim, select this segment and select this segment, we trim it. Now we have to draw this segment. Okay, this one, diagonal. Okay, I divide it into 10. Okay, 10, and we have to model diagonal again. This one. You can copy it, but in this model I just try to model to show you how to draw it, but actually you can save your time by copy. And I have to create an upper frame 6 meter 3 6. Okay, in the location, and I can and I can trim it later. Now I have to add other diagonal. I have to check on snipping, click on drawing line again, and we can trim it by clicking this segment and trim another segment. Okay, now we have to complete the left frame, and we need to add other segment in the right frame, but we don't want. We have to mirror the left frame to other side. Okay, but we don't waste time too much. We have to assign the property of the section, then we mirror it later by create textural and add the section from library. We import it from the library, and we start from the European hollow section how to, and from the column section. Okay, we have to choose for the column section is 420. Okay, and 8mm. Load it, and from other column is 225 multiply 150, 225 150 multiply 5. Okay, and for the upper chart we use the same. Okay, and the lower chart we use the same, and for the diagonal we select 200 multiply to 200 multiply to 120 multiply to 6. Okay, and for other diagonal we select from the square section 70 multiply with 2.5. Okay, 2.5. and now we have to assign all the segment to, we have to seal it. You remember, always seal your model. Start from here, it is the not 300. We have to select section for the column is 400 multiply 200, not this one. Okay, now we have to change it. You can select on this section and remove it, and I import it again by 400 multiply to 200 multiply 58. Okay, load it. Okay, and you click on this one. Okay, and for the column we click from this one. Okay, and for the upper and lower chart is the same, and for this frame is the same, and we have to select on 200 multiply 120. We have to add it in the location. Okay, the location. I select it the same. Okay, you can correct it later for your model. And this one I click on. Okay, and for this one we select from the square section. You have to assign square section. Okay, you have to make sure it is correct with your section assigned. Okay, and we have to draw another diagonal in this direction. Okay, I select from this one. I have to click on draw. Okay, you can draw it from here to here, and last one is this. Okay, now we have to assign the support. I click on the support. We have to select this support type, click on here and click on here. Okay, let's see again. And you can change your grid line by clicking on setting grid. In grid line you can set up in set direction. Okay, set direction to 40. Okay, and you can change in it by direction, but now I have to change for the set direction only. And we have to mirror it by clicking on mirror and copy, click on here to here. Okay, here to here, and we have to add another frame in the middle location by starting from the beam, and we click on this one section, click from here to here. No, from here to here. Tick correct. Okay, and we have to change it to this one. You can mirror it as you want. Now I have to show you how to draw it one by one. Okay, now we have to connect our section again. Indicate I don't want to model it again. I have to mirror it. See, and you select this segment. Okay, click on the mirror, copy. We have to show in wireframe. Okay, everything now is fine. I have to save it again. Now we have to create a load cache. In this one you can call it the service, and you can create another load cache as you want by create this load cache and create for the variable load or for the line load. Now I have to call it the DL, and for the line load, this one we add another load cache, but line load application in on rows. Okay, on rows we click at LL, and we add another group for the win load. We call it win load, win it. Okay, apply in it direction, okay, and you can apply it in other y direction. If you want to add it in other x in this direction and y in this direction, now you can add win in y direction if you want. Win Okay, call it when it correct. When it. Okay, add new group. Okay, you can call it win and win it direction. Okay, we have to save it again. Now we have to apply for the deload. For the deload, we start it from the 0.3. 0.3 multiplied with the base length is 6 meters. So we apply 1.8, 1.8, 1.8 in the global axis. Okay, in the selection, click on here, and this one click on here. And for the line load, we apply the shoe line load is 0.4 multiplied with 6 meters. It's 2.4. 2.4. We click on the line load and click it again. Click it again. Okay. Now we have to complete it. And we have to click on win it. And this one we click on the win load. And for our structure with no applicable internal pressure, we apply for the internal pressure only. So you have to determine the velocity pressure. Okay, click on here, click on this icon, and determine your type of the terrain, sea, or in the country, or in the city. Now we have select on the countryside, and we select the basic wind speed is 22. Okay, you see here the velocity pressure is 0.6. Okay, we click it again. You have not select any item, so you have to select your column first. Your column. Okay, you click on the load again, and you click on this icon again. Now we have to determine the global parameter. We apply it direction. Okay, global direction, and this row. Okay, the perpendicular, the total length of structure is, we take it 60 because there is the square. Okay, and this length is 60 as well. Okay, so for when we apply perpendicular in different length perpendicular to the wind direction, and for the parallel is this length. Okay, this length, the width length. Okay, the width length. So the structural damping effect for steel structure, we select 0.5. Okay, everything is good now, and we select it for the wall, and the wall side is the wind wall. Okay, the wind wall. You see here the parameter for our frame. The overall height is 19. Okay, 19. The wind direction is 0. And we have to select. Click on OK. And we want to apply at the 0 reference line at the center line. Okay, click on OK. Now try again. Okay, click on OK. You see here it is the internal pressure, and for other side we click on it again, but we change the parameter of wall is the levered wall. Okay, or lever side, and click on OK. but you have to click on the member first before you can assign the load. Now we can try it again by clicking on the remote side. Okay, it's good now. And the other parameter you have to change it again. It's 19. We have to apply it. Okay, and this one is 1.020. okay, sorry, because you do not deselect this one yet. We try it again, clicking on load. Okay, everything is good now. 19. Okay, click on apply. Okay, this is for the windward direction, this is for the leeward direction, and we also apply in this direction also. We have to click on the rows, and we click on the distribution load again, and we change it to the pitch rows, and you have to check it again. Yes, it's correct now. And this one, okay, the parameter for the slope of the rows, you can check it if you want. Now I have to check this rows. We can go to make sure it's correct with our concept. We have to draw the member to here, and you select on the measure the angle, click this element and click this element and check it. A 9 plus 7.59 is correct. Okay, now we have select on it again and click on load on wind. In this one we have to make sure we click on the pitch road. Okay, we have to say in slope is the pitch road. Okay, and the frame is correct, the I and alpha is correct, 7.59, and the wind direction is here. And you have to check about the locate. In this one, in locate 1, in the fs, okay, in the s is the minus. So the wind will go upward. Okay, go upward. And you can check for the 2 is in compress. Okay, in compress in azure, and you can check for the load case 2, but I think load case 1 is maximum, and load case 4 for compress. Okay, you have some compress in this side and a little upward in this area. Now you have to click on 1, okay, to make sure you got the maximum value. Click on OK, and you have to make sure your structure is 0, okay, in each direction, and the frame distance is 6 meters. Okay, from one bay to other bay is 6 meters. Click on OK, and click on this symbol. Okay, you can see here everything is working automatically. Okay, automatically. The wind load action on a rope for the zero code not apply in the same magnitude, but in this segment got higher value of the upward force, and for this segment got another value of the force, and this one is got higher value of the upward force. In zero code not apply the same magnitude in the whole frame. Okay, it is very special in each code you have to check it. Now you can check about the load again, did load, grow for the line load and for the win load. Now I have to start for the load combination. Click on it, I delete it and generate load combination by clicking the ultimate state and characteristic and click apply. You see here, this is the combination or it load care. For the load care 1 apply for the did load only, and load care 2 apply the did load and line load, and for the load care 3 apply the did load, line load and win load, but issue for the win load. And this one, the lead the action is win load and the did load. Okay, you can check the alternative load combination in here. It is the ratio or combination. So here the 1.35 multiplied the load blah 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 blah. You can check it here. I had to click on the seal to make sure the structure is sealed. Now we have to click on analysis, but you have to make sure you input correct the boundary or the support. Okay, we have only 4 support but no other restraint at the top. It is easy to error when you model like this one. You have to make sure you control set to assign the restraint for 2D frame, and let's start again for the structure and click on model. Now I have to add insert direction by clicking this one and this one, and you have to make sure your support is so properly. Okay, try it again. Okay, now you can copy it, or you can click it one by one. In this case I want to copy it. Okay, click on here to here. You can click one by one, or you can add the number of the copy. Okay, now I have to add 1. Okay, you can select it, copy it again, copy it again. Okay, now you can check it for the bottom. I have to add in this location, and this one I add to the location and the location, and you can choose the upper restraint or lower restraint according to your analysis. Now I want to add the restraint in the column. Okay, you can add here to here, and for the optimization you can optimize on your model how to improve more for the pressing and how you can withdraw some pressing. Now I click on the point support insert invite, and now I have to copy it by using mirror. You will double this restraint. Now so you have to click on select to make sure it now select. Okay, and click on copy mirror again, click on the location to the location. Okay, now everything is fine. I had to show only for the structure frame. You can check here. Okay, you can check here. Now we have to start to analyze it and to feature the model problem by observe on the buckling shape, by observe on stability. Now we have click on the analysis, and we start first one from the analysis in the critical for the elastic analysis, but for the second order and buckling we not yet perform. Now we have to try to determine the first order analysis first. Okay, click on calculation. You see here there are some member overlap each other. You click on geometry and click on select. Okay, you see here this member is overlap each other. Now we press escape and click on select this one and delete it. Okay, delete it. Okay, now we have to try to analyze it again, and each error appear we have to fix it. Okay, you see here perform diagnostic to make sure your structure is don't have any error. In the case we have any warning, we have to make sure to fix it. Distance between bar is too small. Click on here and select this one. What does it mean? Is too small. Now I have to click on it and delete. Because it's too small, we have to change it. Okay, we have to copy it again. Now we have to mirror it. This one is correct or not? Okay, now we have to draw it again. We have to copy it again by clicking this one, copy, and this one copy. And we have to start again from analysis, and we have to perform it. No other error. Okay, now it's perfect. We have to seal. In the case you can perform the second order analysis or buckling mode to check, but now I have to check it in the visibility as clear as possible to know about our deformation. I want to know about dislocation. Another one is dislocation, and at the middle. Okay, now you can check for the load combination 6 visibility. Your structure is deformed in that direction. Okay, you deform in global in 8 and for this frame is deformed in that direction is 72 millimeter. And you have to check it with the permissible deflection to make sure it pass the requirement. Okay, and for the combination 7 is only 60 millimeter. H is around only 15, and deformation in each direction is 6. Okay, you can see here the deformation in each direction. Now it's very small. Okay, in each direction is very small, and this one is acceptable. You can to seal it again. And now we have to click on this icon and click on elastic analysis, second order buckling and we have to perform all the analysis to check the structure again. For the option, we will take a longer time to analyze the design. The combination 1, the request number buckling mode is not high enough, so you have to increase it each one to make sure it reach the exchange value. And these two, combination 2, 3, 5 is the same. Okay, now we have to click on the load combination and to perform it again by clicking here. 1, 2, 3, 5. We have to increase it 2 times to 20. Okay, 20. Now let's try 220. 20 upper limit reverse buckling change value is 10. Okay, now calculate this again. The request number buckling mode is not high enough. You see here indicate you have to increase more limit by correct on the previous option. You see here 2, 3, 5. Now I have to increase it again. 2, 3, 5. 2, 3. Now I have to increase it to 50. Just increase to 50 and 50 again, and calculating it again. When you increase the interaction will run is more longer, but it's not necessary. You do not need to increase the view. For 2 and 4 you can increase it again. 2 and 4. Combination 2, I increase it to the 50, and 4 we increase it to the 100 this time. Okay, see here the running analysis will take longer time when you increase the interaction. And this one is the combination 4. There is no relevant buckling result because all exchange value are higher than the given limit. Okay, it's very good. Now we have to seal it again. Okay, start from the load combination. You can check it again for the load combination serviceability. Okay, and for the load, for the light load only, and for the wind load. Okay, has in each direction deformation, and you can check for the envelope. Okay, envelope you see here about the deformation. You can check it to the internal force. Okay, internal force. You see here in this segment got higher internal force, and this segment also got higher internal force. So in the case in this segment in that part, you can increase by adding more pressing or increase the section. And this one got higher the internal force, and you can check for the by as well. This one is high. This location is high, and this location is also high. So now we have to check about the buckling. Click on second order. You can compare the first order with second order effect, but now I have to check about the buckling. Okay, you can check here. We start from the load combination 1, and the exchange value is 5.85. each high HM value. Now you can check if the local buckling in the diagonal. No global buckling occur in the frame. It is very good and suitable for our concept. Now I had to spot check. Okay, everything is about the local buckling. Okay, now we have to check about the load combination tool. The HM value is decreased from the 5.85. You remember about load combination 1 is for the ultimate load or the dead load only, and this one for combination with the wind load. Okay, the HM value is only 2.95, and you can check here. You can check about your load combination the previously. The load combination 2 is dead load, light load, 3 dead load, light load, and wind load. Okay, now we have to check it again about the buckling and load combination 2, dead load and light load. Okay, in this case it is the very low HM value than other case, so you have to focus about this one. Okay, let's start from here, and now you have to check it again. In this case it the action dead load and light load only, and start here. Okay, the buckling is occur at the local buckling at the diagonal. Okay, now we have to check for the combination dead load, light load, and wind load. Now you can check here. Okay, it is also the local buckling. In the case you can check about buckling sensitivity for its load case. The buckling sensitivity for the location is in the diagonal in the location. You can see here in the location, and you can check for the other combination. It's the same in the location. In the same education, and so you can fix it by add another diagonal. Okay, and now we have to perform the global check, global design. Okay, by click on the first order analysis, and now we have to perform for the cross section design only. The next step we will perform with the buckling and compare each other. Okay. You see here in this one in the bar B1 the element number node, and it appears at the node, and the load combination control is load combination 2, as I told you before. You can see here the load combination 2, the lower HM value. Okay, and the examination is the general elastic cross section, because we perform it in elastic cross section analysis and design that perform include the buckling and the second order analysis. And for the listen ratio, the design ratio is 92.5. okay, 92.5. Now we have to check about the ratio where is location. Okay, it appears at the column. You see here at the column. At the column is around here, so you can add another pressing at this one and increase it again. In this case, now I had to come back and I had to perform the buckling. The result will be change too much from the first order analysis to second order analysis. You can check here. We perform and calculate it again. Now the result is 93%. Okay, 93%. A, the general elastic corrosion resistance. and for the location is controlled by the global stability, okay, in the location. So you have to make sure, okay, you add another restraint here, okay, correct. Now we have to check the global again and click on the location. You can check it, okay, this location you can check it, the location you can check every element. Now we have to come back about analysis to make sure the structure is path for the deflection. Select on the serviceability and click on deformation, okay, and the location sorry, okay, 72. You have to have spot check about the calculating. I had to 60 meter divided by the 72.1 is 800. So you have to perform a quick check to 60 meter length divided by 350 is around 171 for the permissible deflection. Your frame is okay right now, and the very important for the horizontal deflection, you have to check it about the horizontal deflection 1.1. Okay, so when it is very good, the maximum is only 8.5. You can check it again, okay, 8.5. It's really good for the lateral displacement. Okay, now we have to come back and fit our model. You see here in this one you got the maximum design ratio in here. Now I want to issue by adding more pressing. I select this one, 200 multiplied by 120. Okay, 200 120. I can add it to the location. And add it again. And you can add to other one. No, I start from here, okay. It's a noise, so you can select another one, it's the same. Okay, and now we have to add another location, another analysis load. We add the national load global infection to include the effect of global infection. Apply national load. We apply the maximum one is 0.3%, and we include it all load combination. Click on apply, and the initial sphere we add new. We add in the interaction according to our wind load, and okay, we keep everything default. Click on apply. Okay, now you can check your load again to make sure your load is correct with your concept. Like load, okay, for the wind load. Now I have to try to create another new load combination. I delete this all, and I try to click it again and apply. Okay, Okay, save it, and you have to click on analysis. In the option we perform, include the global setting, the initial sphere that we was set up, and we have to click on the second order analysis buckling, and you can check the visibility for the second order analysis also, but in the case I don't want to check here. Calculate, you see here the low combination one, the request number buckling mode is not high enough to reach when you include the global effect, so you have to increase more the interaction. Also it's the same, the request number, there is no buckling. Okay, for the low combination one is enough for the interaction, so we had to increase the call load combination 1 2 3 and 4. Now let's start again. 1 2 3 and 4. Okay, 1 2 3 and 4 we had increased 50. Now I increase everything to 80, and this one is also 80, this one is also 50, and we have to calculate this again. In case you don't want to watch time, you can select perform on the critical load combination only, not perform for all load combination. In this one is your computer, it has a lower RAM or has lower capacity. Load combination for this no relevant buckling result because all CPU are higher than the limit. Okay, it is very good. Right now we have to save it. And you have to check about the buckling again. Okay, you see here the buckling include with the load combination, deload and line load. This is the critical load combination. You have to check about this one. It's a local buckling. You can check here about local buckling. And for the maximum deflection is shown in here. You can check, but in this one for the ultimate load combination, you have to check about for the load combination and serviceability. Okay, you check on the border and click on the serviceability. Okay, you can check here the maximum value in subtraction is this one, and scroll down is city, scroll down is 15. Okay, you can check here. Now you can check for the further analysis, and you can check for the envelope load at ultimate combination, and for the internal force. You can check for the internal force by increasing the scale, and you can add the value by adding marker, and this one you also can adding marker. Okay, okay, and you can check it for the this one is for the envelope. Okay, envelope the maximum value for the envelope. You can check for the shear force. in the Z direction. Okay, you can check for the shift force, and you can check for the bending moment. Okay, you see here the bending moment, and you can check for the buckling sensitivity. You see here it location is buckling sensitivity occur in this location, and you can fix it by increase more section or by adding another diagonal, or by adding another pressing here in the location. Okay, now we have to global check again and perform analysis by using scanner analysis, and we also check for the buckling, and we check for the whole frame. Okay, whole frame. And for the elastic stability check, the elastic critical factor, we perform it automatically based on the sensitive analysis of the accelerometer. I showed you previously. We had to calculate it. Okay, now you see here the design result at the location is around now 70. You see here it is 87% it is really good result for our design right now, and you can check for the location is this one. I showed you previously about the analysis and buckling sensitivity. Okay, you see here about the location, so you can add another diagonal to reduce this effect, or you can increase this section, because you see here this section is different from this section. We had to reduce it, so you can increase in the frame, the location. Okay, you can increase the section, and you can reduce from here to here in the case, and your working ratio will be decreased more. Okay, now I want to keep it I don't want to optimize again. You can optimize again, continue optimize and optimize to make sure your texture is working as your requirement. Now I had to check about my model is not correct in the location. I had to move it again. Okay, now we had to move this joint to here. Okay, you have to spot check about your model to make sure your model is clear and clean without any dot. Okay, we have to add another one by copy this one to this. You have to check about your model is working fine, don't have any error. Okay, now I have to seal it, and we perform analysis again. You see here the static analysis, load combination 4, okay, no relevant buckling. Okay, it's good. About buckling, okay, for the control load combination is load combination 2, the load with the light load. You can check the critical load vector here. You see here it is local buckling and has a small fit on the upper short, lower short, okay, you see here, and a small fit on the diagonal. And for this location is for the big effect, okay, in the location. So you can increase more section, okay, you can increase more section in the location, but I don't want to increase it more. We have to global check and we have to perform analysis and design again. You see here, this is the utilization ratio for the design ratio of our frame. You see here in the location, the maximum value reach here. I have to show this model again. In your column right now is working only 80%. Okay, it's good. Okay, around 80% is good. In the location is 80%, around 80 or 87% at the joint. Okay, you see here in the joint or joint in the node C, okay, on the node C or element 132, this element is 132, and the joint is the location at the joint, okay, for the maximum design ratio. And you can check everything on your model. Okay, let's steel dominant calculation and general elastic for the elastic design. Okay, constant, you can check here, and pure design and even plastic interaction. For the plastic interaction got lower result. The design is inelastic, okay, plastic design, and conservative interaction we got here, conservative in global, okay, you can check here the global stability, and with the general coefficient you can check the general elastic coefficient is around 85.1, and your global stability is 87.4, so it means your structure has a good stability. Okay, good stability. Again the global effect. Okay, so you create your model. It's good now. Yeah, it's good. It's perfect for analysis and design. You have another frame to support education, another frame to support an education, and you had to add another diagonal at the connection between the column frame to the row frame, and you had to add another restraint. Okay, so for the 3D you also add the restraint and perform analysis and design again, but for the 2D now we had to perform it only 87%, but for the 3D model this value will be increased from the 87.4 to another %. So you have to make sure your design for the 2D frame is below 10 90% or below that, below than 85% or 80% is pretty good. These are to continue to design for the 3D frame. Okay, now I have to still it again and again because it is very important when you analyze and design it. Okay, you have to check for the analysis, you have to check for the design from the low case, low case, and you have to perform analysis to check for the depiction. Okay, everything is here and you can check it for the load combination, for the squeeze, and for the stability analysis. Thank you for your watching. Thank you.